As we move to simplifying algebraic expressions, we do have to stop and review our properties of exponents. And so with exponents, when we start multiplying, dividing, etc., we have to apply these rules so that we don't have to expand them every time. And so our product rule states that if we have the same bases and we are multiplying them, we can simply add the exponents. An example here is if we have x cubed times x to the fourth, we can simply add those exponents and get x to the seventh. The quotient rule says that if we are dividing like bases, we can simply subtract the exponents. The example here is that if we have x to the seventh divided by x squared, we can subtract those exponents. 7 minus 2 gives us x to the fifth. The power exponent states that if we have a power to a power, we simply multiply those exponents. The example here is that if we have x cubed raised to the fourth, we multiply the 3 times the 4, and we get x to the 12th. If we have a power or a quotient, and it is in parentheses, so we have a multiplication in parentheses and it's to a power, or a division to parentheses and it's to a power, we simply raise everything in the parentheses to that power. The examples here are if we have 2x and it is raised to the third power, we are going to take the 2 and raise it to the third power. Well, 2 times 2 times 2 gives us the 8, and we are also raising that x to the third power. So we get 8x cubed. For division, it's going to work exactly the same. If we have z over 3 and it is being squared, we are going to take the z and we are going to square it. That gives us the numerator of z squared. And we're going to take the 3 and square it. That gives us a denominator of 9. The zero exponent property tells us that anything taken to the zero power gives us 1. For example, if I have 5 to the zero power, I will get 1. And our negative exponent property tells us that anything taken to the negative power is just going to reciprocate it. So if I have a number to the negative power, it's going to be the same thing as 1 over that number to the positive power. Likewise, if I have a negative number in the denominator, it's going to reciprocate it and put it in the numerator. And those examples are if I have 3 to the negative 2, it does not make that number negative. It simply puts that 3 squared in the denominator. If I have a fraction to a negative power, it's going to reciprocate that fraction and make it to the positive power. A term is considered to be simplified when every base is only appearing once, all your fractions have been reduced, and there are no parentheses or negative exponents. So let's look at some examples here. We want to work in a logical pattern. So when I look at something like this, I'm going to simplify this group first before I start combining my like bases. And so to do that, I'm going to take everything in the power to that third power. I'm going to leave the first part of this alone. So I'm going to leave this part alone, and I'm going to take every piece of this to that third power. Now I can go ahead and simplify this a to the 0. That is simply just the number 1. So up here I have 1 times b squared. We know that my identity property tells me I can leave that as b squared. 2 cubed, well, that is going to give me 8. Here I have a power to a power, so I'm going to multiply those. And I'll say -1 times 3 gives me -3. Here I have a power to a power, so I have the b, and I'm going to multiply those exponents. 3 times 3 gives me a 9. And now I'm ready to do some more simplifying. I will always want to put my coefficient or the number in front where it belongs, in the front. I have an a to the -3. These are like bases. The b squared and the b to the ninth is going to be multiplying like bases, which means I'm going to add those exponents. 2 plus 9 gives me b to the 11th. Now, this is not quite simplified because one of the rules of simplifying was that I don't have negative exponents. And so this negative exponent needs to be reciprocated or moved to the bottom. And so on the top, I have 8b to the 11th, and on the bottom, I have a cubed. Now, the second one seems a little more difficult, but I typically try to simplify my numerators and my denominators before I do anything from top to bottom. And so in this case, I would look at those twos, 2 times 2, and I would go ahead and multiply those. Then I would take this n, it is being multiplied by this n. Remember, when you multiply like bases, you are going to add those exponents. So I have -1 plus 4 gives me a +3. And then I have this variable to the 0 power. Remember, that can just be replaced with a 1. And since I'm multiplying, when I multiply that by 1, I still get the 4n cubed. On the bottom, I have a power to a power. When you have a power to a power, you're going to multiply those. -1 times 2. So I have n to the -2. Now I'm not quite done because I still have multiple n's. And remember, simplifying means that my bases appear only once. And so I'm going to apply the rule of division. Remember, when you divide, you are subtracting those exponents. And so my 4 doesn't change at all. My n has a new exponent, 3 minus a -2. So it is n to the 5th. A monomial is a single term expression that contains a constant, a variable with a whole number exponent, or the product of a constant and one or more of those variables. The numerical factor is called the coefficient. So a monomial can be a number, that would be your constant. It could be a variable. It could be a variable with an exponent, as long as the exponent is a whole number. Remember, a whole number is your whole number sets, or you could have a combination, a product of numbers and variables. But it can only be one term. You can't have any addition or subtraction in order for it to be a monomial. A polynomial is when you add or subtract monomials. So you could have one monomial or multiple monomials added or subtracted, and that is a polynomial. There are special types of polynomials. A binomial is a polynomial with exactly two terms. A trinomial is a polynomial with exactly three terms. The degree of a monomial is the sum of all of its exponents. So if I were to take Something like this. Remember, when you don't see an exponent, it's a 1. So the degree of that monomial is going to be 3. A degree of a polynomial is equal to the degree of its highest degree term. So if I have a polynomial, which means that I have multiple terms added together, I'm going to look at the degree of each of these, and I'm going to say, well, the degree of the entire polynomial is the highest of those degrees. Like terms are terms that contain the same variable with the same exponent. That's an example of like terms. This, however, would not be like terms. Even though they have the same variable, they do not have the same exponent. And so you can combine terms as long as they are alike. When I'm adding something like these or subtracting these, I'm going to make sure that I keep my like terms together. You can do this by underlining and make sure that you have taken care of all of the ones. For example, if I have 8x cubed, I'm going to look over here and I'm going to find the x cubed that goes along with that. And then I'm going to look at a negative 4x to the fourth. I'm going to add my like term. And I'm going to do that with until I have taken care of all of my terms in this particular problem. Once I've combined those, all I have to do is add the coefficients. So I have 8 and 5. That's going to be 13x cubed. I have negative 4 and positive 2, negative 2x to the fourth, and I have negative 7 and positive 2. And then for polynomials, you would have talked about this in Algebra 1. You want to list them highest exponent down to your lowest exponent. This is considered standard form. So when you add or subtract polynomials, you are simply combining the like terms and then putting them in standard form. So go ahead and work on number 2.